Good evening, dear students. In previous class, I am explained about the laws of photoelectric effect. I discussed total 4 laws. In today's class, we are discussing about particle nature of light, that is photon. Particle nature of light, heading particle nature of light. Particle nature of light. Light, already you know, light exhibits in the form of 2 types. One is the wave nature, another one is the particle nature. Here particle nature, nothing but photon. Main concept, photon. Photon. Okay, what is the definition of a photon? Photon ಅಂದರೇನು? Photon is a pocket of light energy. Photon is a pocket of light energy. Okay, ಬೆಳಕಿನ ಶಕ್ತಿಯ ಪಾಕೆಟ್ಗಳನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? ಫೋಟಾನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಡೆಫಿನೇಷನ್ ಫೋಟಾನ್. Photon is a pocket of photon is a pocket of photon is a pocket of light energy. Light energy. Photon is a pocket of light energy. ಶಕ್ತಿಯ ಪಾಕೆಟ್, ಬೆಳಕಿನ ಶಕ್ತಿಯ ಪಾಕೆಟ್ಗಳನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ? Photons ಅಂತ ಕರಿತೀವಿ. Photon is a pocket of light energy and its characteristics or properties. What are the main properties of photons? Properties or characteristics. Heading characteristics. Okay, it is very important for 3 months. Mention the properties of photons or write the properties of photons or write the characteristics of the photons. First one character. Photon has energy. A photon has energy. A photon has energy E is equal to h nu. Energy E is equal to h nu. Photon energy ಏನಿದೆ ಇಲ್ಲಿ? Each photon energy E is equal to h nu. ಪ್ರತಿಯೊಂದು ಫೋಟಾನ್ನ ಎನರ್ಜಿ ಏನಾಗಿರ್ತದೆ ಇಕ್ವೇಷನಲ್ಲಿ E is equal to h nu ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು. ಓಕೆ, ಇದ್ರ ಬಗ್ಗೆ ಡೀಟೇಲ್ ಆಗಿ ಮ್ಯಾಕ್ಸ್ ಪ್ಲಾಂಕ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದಾನೆ. ಓಕೆ, ಆನ್ ಡಿಟೇಲ್ ಕಂಪ್ಲೀಟೆಡ್ ಡೀಟೇಲ್ಸ್ ಮ್ಯಾಕ್ಸ್ ಪ್ಲಾಂಕ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಡ್ ಅಬೌಟ್ ದ ಕ್ವಾಂಟಮ್ ಥಿಯರಿ ಆಫ್ ರೇಡಿಯೇಷನ್. ಇನ್ ದಟ್ E is equal to h nu. Max Planck's quantum theory of radiation is equal to h nu. E nothing but here energy. E nothing but photon energy. Photon energy. H nothing but Planck's constant. H ಅಂದ್ರೆ ಏನು ಇಲ್ಲಿ? Planck's constant ಅಂತ ಕರಿತೀವಿ. Planck's constant. Nu nothing but frequency of a photon. Okay, this one is the E is equal to h nu, it is a single photon energy. ಇದಕ್ಕೆ ಏನಿದೆ ಇದು single photon energy. Suppose I want to write number of photon energy, its equation E is equal to nh nu. E is equal to nh nu. Here E means energy, n it is a number of photons, h it is a Planck's constant, nu it is a frequency. Okay, E is equal to nh nu, it is a number of photon frequency. First one property or first one character, a photon has energy is equal to h nu. First one over. Then second one, the momentum of photon. The momentum of photon is momentum denoted by symbol P. P is equal to h nu divided by c. P is equal to P, nothing but momentum. Momentum is equal to h divided by c. How it comes? Already know the definition of momentum. Its equation P is equal to mv. Then in that de Broglie equation, it's a wavelength lambda is equal to h divided by mv. H divided by mv. Here product of Max Planck's momentum of photon is P is equal to h nu divided by c. Okay, how to write P is equal to h divided by c? ಹೆಂಗೆ ಬಂತಿದು ಆಲ್ರೆಡಿ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಿದೆ ಎಮ್ ವಿ ಅಂತಿದೆ, ಕರೆಕ್ಟಾ? ಮಾಸ್ ಇಂಟು ವೆಲಾಸಿಟಿ. ಇಲ್ಲಿ ನೀವೇನು ಬರಿತಾ ಇದ್ರಿ? ಮೂಮೆಂಟಮ್ ಆಫ್ ಎ ಫೋಟಾನ್. ಮೂಮೆಂಟಮ್ ಆಫ್ ಎ ಫೋಟಾನ್. ದಿಸ್ ಒನ್ ಇಕ್ವೇಶನ್ ವಿ ಆರ್ ರೈಟ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಡಿ ಬ್ರಾಗ್ಲಿ ವೇವ್ಲೆಂತ್ ಇಕ್ವೇಶನ್. ವಾಟ್ ಇಸ್ ದ ಇಕ್ವೇಶನ್ ಆಫ್ ಡಿ ಬ್ರಾಗ್ಲಿ ವೇವ್ಲೆಂತ್? ಲ್ಯಾಂಬ್ಡಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಚ್ ಡಿವೈಡೆಡ್ ಬೈ ಪಿ. This one is called as de Broglie wavelength equation. Lambda it is called as wavelength. H it is Planck's constant. P it is a momentum. Therefore, P is equal to h divided by lambda. Okay. Illi already know the relation. Here already know the relation. C is equal to nu lambda. We are learning in first year class. C is equal to nu lambda. C it is the speed of light. Nu frequency, lambda wavelength. Then lambda is equal to c divided by nu. Substitute in the place of lambda nu divided by c. P is equal to h divided by, in the place of lambda, c divided by nu. C divided by nu. When it goes to numerator side, its equation becomes P is equal to h nu divided by c. This one you call as momentum of a photon. Momentum of a photon. Next, third one property, photons travel with the speed of light. Photons travels with the speed of light, that is 3 into 10 to the power of 8 meter per second. Photons are travel with the speed of light. Okay, photons na ವೇಗ ಬೆಳಕಿನ ವೇಗಕ್ಕೆ ಸಮಾನವಾಗಿರುತ್ತದೆ ಅಂತ ಹೇಳ್ತಾರೆ. Photon speed, it is nearly equal to the 3 into 10 to the power of 8 meter per second. Okay, this one is the third one property. And fourth one property, photons are electrically neutral. Photons are electrically neutral. Okay, photons are the neutralized particle. Alpha, it is the alpha particle, it is the positive charged particle. Beta, it is a negative charge particle, gamma it is a neutralized particle. Here photons are the neutralized particle. Here there is no any charge of the photons. They are electrically neutral. Photons are electrically neutral. Photons are electrically neutral. Sorry, electrically. Photons are electrically neutral. Then, fifth one, the rest mass of photon is 0. The rest mass of photon is 0. When that photon it is in rest position, its mass is considered as 0. The rest mass of photon value is 0. Number 6 one. Photons behaves as particle. Photons behave as particles when it interact with matter. When it interact with matter. ಯಾವಾಗ ಫೋಟಾನ್ ಪಾರ್ಟಿಕಲ್ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತಂದಾಗ ಯಾವಾಗ ಇದು ಮ್ಯಾಟರ್ಗೆ ಇಂಟರ್ಯಾಕ್ಟ್ ಆಗುತ್ತೋ, ಕೊಲಿಷನ್ ಆಗುತ್ತೋ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಪಾರ್ಟಿಕಲ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗುತ್ತೆ. ಫೋಟಾನ್ ಈಸ್ ಬಿಹೇವ್ಸ್ ಲೈಕ್ ಎ ಪಾರ್ಟಿಕಲ್ ವೆನ್ ಇಟ್ ಈಸ್ ಇಂಟರ್ಯಾಕ್ಟ್ ವಿತ್ ಮ್ಯಾಟರ್. ವೆನ್ ಇಟ್ ಈಸ್ ಕೊಲೈಡ್ ವಿತ್ ಮ್ಯಾಟರ್, collision with matter, interact with matter, at that time that photon is behaves like a particle type. Okay, these are the main characteristics or properties of a photons. Okay, up to here the main definition of photons and its properties or its characters over. Then next one, very important concept, that is the matter waves. Matter waves, or it is also called as de Broglie waves or de Broglie waves. Matter waves or de Broglie waves. It is important for 2 marks. What is matter waves? What is matter waves or de Broglie waves? Definition: the waves associated with a material particles in motion. The waves associated with a material particles the waves associated with a material particles in motion are called matter waves. The waves associated with a material particles or moving material particles in motion are called as de Broglie waves. For example, I am considering this one is wave, it is in under motion. Okay, this one wave consists material particles or particles. These particle is in under motion along with the wave. This one you call as matter waves or de Broglie waves. The waves are associated with a moving material particles in motion. Okay, this wave it is in under motion and it is associated a particles. These are the particles. Next definition, de Broglie wavelength. De Broglie wavelength. Definition, the wavelength of the de Broglie wave or matter wave we call as de Broglie wavelength. Definition, the wavelength of a matter wave, the wavelength of a matter wave is known as de Broglie wavelength. De Broglie wavelength. De Broglie wavelength. For example, I am considering the matter waves or de Broglie waves like this. These are the de Broglie waves. These are associated with the material particle. Associated with the material particle. The distance between these two crests, the wavelength of these waves, we call as de Broglie wavelength. The length of the de Broglie wave or matter wave, that one we call as length of the de Broglie wave or de Broglie wavelength. The wavelength of a matter wave or de Broglie waves is known as de Broglie wavelength. Okay, it is denoted by equation lambda is equal to h divided by p or lambda is equal to h divided by mv. Here lambda we call as wavelength of the de Broglie wave. Wavelength, h it is a Planck's constant, m it is called as mass, v we call as velocity of a particle. Okay, this we call as de Broglie wavelength.